Okay, so I'm making a little video for you about how to determine the percent of death rate from a toxicity sample and how to determine the LD50. And LD50, remember, is the lethal dose 50. It is the dose that will kill 50% of a population. So we have two different chemicals. Over here we have sodium cyanide, and I'm going to be doing the calculations for sodium cyanide in red. And then over here we have arsenic, and I am going to do arsenic in purple. And you'll see why I'm using different colors when we get to the graph. So first thing that we have to do is we have to calculate the death rate. And the death rate is a percent. And so if you recall from math and from other things we've done in science, percent requires us to know the total sample size. So in each of these different cases, we have a different sample size. So up here is the sample size for sodium cyanide. So I am going to calculate the first death rate for the dose of 1. So over here, these are the dose values, and they're just kind of in arbitrary units right now. It's not the number of doses necessarily, it's the amount in a dose, but don't worry too much about what those units are. So for the dose of 1, we had 8 deaths in 190 sample size. So that ends up giving us a percent of 4.2%. Okay, so you're going to do that all the way down and calculate the percent all the way to the bottom. Now you'll notice over here I had to add 7, 8, 9, 10. For some reason when I made my original table, I did not have those. I'm pretty sure your template does have them built in, so you shouldn't need to worry about it. If not, add them in there like I did. Okay, so now I'm going to do a death rate calculation for arsenic. And so the sample size for arsenic is 210. So this is why we have to pay close attention. And we have different dose values as well. And that'll become important when we do our graph. So if we take 2 divided by 210 and we multiply by 100 to get our percent, we actually have 0.95%. Now, if we're rounding to the nearest tenth of a percent, that means our death rate is 1.0% in this case. Okay, so keep going and you will do all of the calculations so that you have a value in the death rate percentage all the way down. This is what you're going to use to plot your graph on the facing page. So you're going to be using, let me get my little highlighter here. No, that's my eraser. My highlighter here, you're going to be using the dose and the death rate for each of these, okay? So those are the two columns that you need for the graph. So if I go to the graph now, you'll see here that I have my dose value at the bottom, and then I have percent mortality. And percent mortality is the same thing as a death rate. I guess I just decided to make life more challenging by giving you a different title than what was in your table. Because I was running out of space, I actually have the percent values over here. But it doesn't really matter. It's still the same thing. So I'm going to start by plotting my first point over here for sodium cyanide. And if you'll remember, we had 4.2% with a death after 1 dose. So 1 dose is down here. And we had 4.2%, which is going to be sort of there. It's hard for me to do this with a stylus, but it should be just under the halfway point to the 10. And now if we do the same thing with our arsenic, if we look back here, we had 1% after 2 doses. And so 2 doses is right here. And we had only, oh, my stylus is being silly. And we had only 1%, so it's going to be really low down here. Whoops, 1. Now, what you're going to end up seeing when you plot this is you're going to have 2 graphs. And the graphs are going to look a little something like this. Okay? Now, don't just draw them like I am because I'm just freehanding it. So your graphs will look something similar to this. Oh, except I went above 100%, but whatever. And you are going to use them to determine your LD50. And we do that because we know that lethal dose 50 is the amount that kills 50% of the population. So we go over here and we find 50% on the y-axis. And we draw this line. You can do it with a ruler, or you can just follow. And you can see we have a point there and we have a point there. And we're going to bring these down to the x-axis. And these numbers that you find will be the lethal dose 50 for each of the two chemicals that you're plotting the data for. That's how you find your LD50. Hopefully this helps. If not, make sure that you send me an email or a message or hop in a meet. Okay?